Refraction of light. Refraction of light. When light rays travels from one medium to another medium, optically different dense. It is optically different denser. If it is moving from one medium to another medium, and the medium, second medium should be transparent. That is, when the light is, this is the medium 1, medium 2, this is medium 1. When light travels from one medium, this is the boundary of two medium, which we call it as a interface. Interface means the region which separates both the medium. This is the medium, so this is the second medium, and this is air as a first medium. Let us assume air as a first medium and different other medium 2. When it travels from one medium to another medium, when it enters the second medium, it bends. It bends. This is supposed to move like this. This is the normal at this point. It bends when it is entering in the second medium. The bending of light rays. The bending of light rays when it is entering the second medium is called refraction. That is, the bending of light ray when it is traveling or passing from one medium to another medium. Both medium have different density. Both are different density. It is one medium may be denser than the other medium. It bends when medium travels from one medium to another medium. It bends from its path when entering the boundary. We call it as interface of the second medium. This phenomenon of bending of light from its path is known as refraction. Refraction of light. It means when a light moves from one medium to another medium, both have different optical density, both are different optically denser. This is its normal path, but it bends away or towards the normal. This is the normal. So this phenomenon of bending of light when it moves from one medium to another medium is called refraction. So in different medium, the light travels with different velocity. It travels with different velocities. So it means velocity of light in air or vacuum or free space is c, which is equal to 3 into 10 to the power 8 meter per second. But when light travels to another medium other than vacuum or free space, its velocity changes. If it is a denser medium, its velocity it decreases. So travels with the different velocities, and this velocity of light is related with refractive index of the medium. So we define, no doubt, when a light travels from one medium to another medium, both have got different density. Its velocity changes, its wavelength changes, but one thing which certainly not changes, that is its frequency. Because the frequency, whether traveling this medium or this medium, it does not change. It is the frequency depends upon the source which producing the light. So frequency never changes. It may pass through any medium. Absolute, now we call one term absolute refractive index, which is denoted by the letter mu or small n. Absolute refractive index is defined as ratio of velocity of light in free space to the ratio of velocity in that medium which we are considering. That is, velocity of light in vacuum to the velocity of the light in the medium. So we can say absolute difference is equal to velocity of light in vacuum to the velocity of light in the medium. So for air, refractive index of air is equal to velocity of light in free space divided by the velocity in that medium. Here the medium is air, therefore in C by V we write C, the velocity of air in that medium. Air medium is C, which is equal to 1. Therefore the refractive index of air or free space is equal to 1. Mu is equal to 1. Refractive index of air. The refractive index of air. Therefore, the refractive index of a medium is equal to velocity of light in vacuum to the velocity of light in the medium. For refractive index of air is equal to C divided by the velocity of light in that medium, that is air, is equal to 1. And since velocity of medium is equal to C by V, if the velocity of the medium, or we can write velocity of the medium is inversely proportional to velocity. It means if the velocity is increasing, the refractive index will be decreasing. Velocity is decreasing, the refractive index will be increasing. For denser medium, the light will travel faster, that is with a velocity of light in the free space is equal to 3 into 10 to the power 8 meter per second, and that is the fastest velocity of light that is in the air. But in the medium, as it's denser, the medium is denser, its velocity will be less than that of the velocity of light in the air or vacuum. Therefore, velocity of light in media other than air will be less than that of the medium. That is, velocity of medium is less than velocity of light in air. That means what? Since the velocity is less in the media, refractive index will be more. It means more the denser the media, the velocity will be less, and its refractive index will be more. More mu is equal to C by V. Less is the velocity, more is this one. It means velocity will be less in denser medium. Velocity will be less, and its refractive index will be more, since both are inversely related. Since velocity of the media is less than velocity of force. So for an example, the refractive index of water is equal to 4 by 3. Refractive index of glass is equal to 3 by 2. So it means as compared to the refractive index of free space is equal to 1. Since the refractive index of water is more than refractive index of air, it means its velocity, the velocity of light in the water or in the glass will be lesser than the velocity of light in the air. For different media has got different optically differently denser for different media. Velocity is now let us take it to media first. What is rarer media and denser media? In denser media, velocity will be less, velocity of light will be less. In rarer media, the velocity will be more as compared to the denser medium. So denser media means the velocity will be less. Suppose this is medium 1, this is medium 2. Say it is rarer medium. Rarer medium, this is denser medium. Denser medium. So rarer medium, this is its velocity, this is its velocity in this medium too. Since this is rarer medium, its speed will be more than the velocity of light in the denser medium. It means we can write V1 is greater than V2. V1 is greater than V2, and since V1 is greater than V2, we can say its refractive index of 1, a refractive index of 2. Since it is in the velocity is less, this is refractive index is more. It means refractive index of medium 1 is less than a refractive index of medium 2. That is, we can say refractive index of medium 1 is equal to velocity of light in free space divided by velocity of light in that medium, and velocity of light in the second medium, this is rarer medium, denser medium, velocity of light in the air, in the free space or vacuum, and velocity of light in the denser medium. If you take mu2 by mu1, mu2 by mu1 is equal to C by V2 by C by V1, where C is the velocity of light in free space. It's equal to V1, this and this cancels, V1 by V2. As we know, the velocity of the light is given by the relation frequency and wavelength. So V is equal to frequency, velocity is equal to frequency multiplied by wavelength. So V1 you can say frequency into wavelength in the first medium, frequency in the wavelength in the second medium is equal to lambda 1 by lambda 2. So it means we can write mu2 by mu1, that is refractive index of second medium by refractive index of first medium is equal to velocity in the first medium, velocity in the second medium is equal to wavelength in the first medium, in the wavelength in the second medium. These both are directly related, these are inversely related. Hence, refractive index in the second medium by first medium is equal to velocity in the first medium, velocity of light in the first medium by velocity in the second medium, wavelength in the first medium by wavelength in the second medium. Bending of light. Bending of light. When light passes from rarer to denser medium, let us first consider rarer to denser medium. Rarer to denser medium. When it passes from rarer to denser medium, this is the interface, the boundary which separates both the medium. So this is, we call it as a medium number 1. This is medium number 2. This is a rarer medium, denser medium. So when light is incident on the boundary, that is interface. This is interface, incident ray. At the point of incidence, we draw the normal. This is the normal. At the point of incidence of the ray, this is the boundary, and it passes, it is supposed to pass like this in the second medium. But instead of that, it will bend away or towards the normal. It is with respect to normal, it will bend away or towards the normal. When it is passing from rarer to denser medium, the velocity of the first medium, since it is rarer, it is less denser. Its velocity, this is velocity of the second medium. Velocity of the first medium is greater than velocity of the second medium, because this is rarer, this is denser. More the denser, velocity will be less, velocity is less, so refractive index will be. Since the velocity of the first medium is more, in terms of refractive index, so it means the refractive index of first medium will be less than the second medium. More the denser, less the velocity, and less the velocity, more the refractive index. In terms of this is angle of incidence, angle of incidence with respect to normal, the incident ray makes with the angle, makes with the incident ray. So angle of incidence I is great when a light strikes on this from rarer medium to denser. When light incident on the boundary of the second medium, it bends towards the normal. It bends towards the normal. It is supposed to go like this, but it will bend towards the normal. With respect to normal, it bends towards it. So with the normal and the refracted ray is called angle of refraction. It means in case of when the ray passes from rarer to denser medium, the angle of incidence is greater than angle of refraction. So we can say when light passes from rarer to denser medium, it bends towards the normal. Okay, when light goes from denser to rarer medium, so this is the boundary of both the medium. This is medium 1, denser medium. So like light is incident on this with respect to normal, and it is supposed to go like this. But since it is from rarer to denser to rarer medium, this is medium 2. Since it is a denser medium, this is velocity of first medium, velocity of second medium. So from denser medium, the velocity will be less. It means V2 is greater than V1. The velocity in the rarer medium, that is second medium, is greater than the velocity in the denser medium. So V1, V2. And what about the refractive index? Refractive index first medium, refractive index of second medium. Refractive index second medium, since its velocity is less. If the velocity is less, then refractive index will be more. It means we can say V1 refractive index of the first medium is more than the refractive index of the second medium. So since it is rarer medium, velocity is more and refractive index is less. Now third, when light passes from denser to rarer medium, what happens? It will bend away from the normal in the second medium. So this is the angle of refraction. Angle of incidence is less than angle of refraction in this case. It means when light is passing from rarer to denser medium, it bends towards the normal, and angle of incidence is greater than angle of refraction. Angle of incidence is greater than angle of refraction. When it passes from denser to rarer, angle of incident will be less than the angle of refraction. There is one condition where the light does not bend away or towards with respect to the normal. When a light ray incident normally, that is at 90 degrees to the interface. This is medium 2, this is medium 1. When it strikes and it goes straight away without any bending. In this case, whatever may be the, this is V1, this is V2, whatever may be the media, this media 1, media 2, but the light will straight, it will pass through and through, straight. It will pass in the second. So here angle of incident and angle of refraction both are same, because the normal is also drawn with respect to the incident ray. So in this, only in this case, when light rays incident normally on the interface, that is when it is going to the second medium, it will neither bend away nor bend towards, it will go along with the normal. Therefore, refractive index in the second medium by refractive in the first medium is equal to velocity in the first medium by velocity in the second medium is equal to wavelength in the first medium in the wavelength in the second medium. Or mu2 by mu1 can also be written as mu21. It means this is to be read as refractive index of second medium with respect to first medium is written as refractive index of second medium with respect to first medium. If you write mu12, that is refractive index of first medium with respect to second medium. So therefore, mu2 by mu1 is equal to mu2 by mu1 is equal to mu21, which is mu2 by mu1. So we can say refractive index of water with respect to air is equal to refractive index of water with refractive index of air, which is equal to 3. Water is 4 by 3. Refractive index of water is equal to 3 by 2, and a refractive index of air or vacuum is equal to 1. Free space. So divided by 1 is equal to 4 by 3. That indicates what? This is water, this is air. The refractive index of water with respect to air is nothing but the refractive index of water. Same way, refractive, if it is in place of water, it is glass. The refractive index of glass with respect to air is equal to refractive index of glass by refractive index of air is equal to, since refractive index of air is equal to 1, this is equal to 3 by 2 by 1 is equal to 3 by 2. This we call it as an absolute refractive index. Anything which is compared with respect to the vacuum, refractive index of vacuum, that is called as absolute refractive index. Now relative refractive index, relative refractive index. Refractive index of water with respect to glass is equal to refractive index of water with the refractive index of glass, which is equal to refractive index of water is 4 by 3 by 3 by 2 is equal to 4 by 3 into 3 into 2 is equal to 8 by 9, which is less than 1. It means the refractive index of water with respect to glass is less than 1. That means what? The refractive index of water is less than refractive index of glass. And same way, refractive index of glass with respect to water can be written as refractive index of glass with respect to refractive index of water. Glass is equal to 3 by 2 into 4 by 3, which is equal to 9 by 8. It means refractive index of glass with respect to water is greater than 1. So this way, but one thing is that velocity velocity is changing with the medium, and wavelength also changes with medium. That one thing which does not change is its frequency, whether it is going one medium to another medium or any number of medium, the frequency of the light will never change.